Today we will be looking at multiplying and dividing in scientific notation. Okay, and what you're going to do for this is you are going to, number one, multiply the coefficients together. And you may or may not remember this from your past math courses. You are going to add the exponents to get the power of 10. So you're going to multiply the coefficients and you're going to add the exponents to get the power of 10. And then thirdly, you will put it into scientific notation, correct scientific notation, if it isn't already. Scientific notation, if it isn't already. Oh, and by the way, this is 2.2.A on page 25. There we go. And finally, you will round to the correct number of sig figs. And you will be using, because we are multiplying, right? Because we are multiplying, we are going to use the multiplication rule for sig figs. So multiplication division rule for sig figs. And can you remember what that rule is? Pause the video for a moment and ask yourself, can you remember what the rule is for multiplying and dividing with sig figs? Hopefully you remembered. You are going to round to the least number of sig figs in the question. Round to the least number of sig figs in the calculation. Okay, so for example, we might have 3.42 times 10 to the 5 multiplied by 4.67 times 10 to the 9. So number one, we're going to multiply the coefficients. Okay, so multiply the coefficients. So 3.42 times 4.67 is equal to 15.97. Second thing you're going to do is you're going to add the exponents. So we have a 10 to the 5 and we have a 10 to the 9. Okay, there's our 5 and there's our 9. So we're going to actually take 5 and 9 and add them together. Okay, so we're going to have 5 plus 9 is 14. And that's going to be our new exponent, 10 to the 14. And so our answer then, we just combine those two, answer is 15.97 times 10 to the 14. Whoops. That wasn't step 3, although that would be at step 3. Answer, you're going to put your answer in correct scientific notation. Is this number in correct scientific notation? Hopefully you said no. You need to have a single non-zero digit in front of the decimal. So you look at this and you say, uh-oh, I have 2 digits, so I need to move my decimal place one position to the left. So now I will have 1.597 times, now this part of the number got smaller by 10 to the 1, right? We went from 15 to 1.5, so that got smaller by 1 power of 10, by 1, we only moved the decimal place one position. So what that means is that our other half of the number has to get larger by a power of 10 to the 1. Okay, so we would look at that and say that would be then times 10 to the 15. And the reason that we make one half larger if the other half gets smaller is that, let's say you had 2 times 6, which is equal to 12. Well, let's say I made 2 bigger and I turned it into a 3, right? That got bigger. If I still want this to equal 12, then the other half of this multiplication has to get smaller. In this case, it's going to be a 4 because 3 times 4 equals 12. All right, so we now have our answer, but we have to make sure we have it to the correct sig fig. So correct scientific notation and then correct sig fig. So we go back and we say in our calculation, we had 3 sig figs and we had 3 sig figs, so our final answer must have only 3 sig figs. So our final answer then will be 1 point, and this 7's going to round that up to a 0, so that's going to be 60. 1.60 times 10 to the 15. And if I've been showing my work, I'm going to want to box my final answer so that someone reading my work can easily see what I want my final answer to be. Okay, so it draws the attention right there by boxing your final answer. All right, one more example here of multiplication. We have 2.93 times 10 to the negative 2. This is incorrect on your worksheet, by the way. The question is wrong, so you might want to correct it for yourself. Times 8.3 times 10 to the negative 5. Okay, so these numbers on your worksheet on page 25 are incorrect, and you'll want to change them to these numbers. Okay, so that's on page 25. All right, and we get multiplier coefficients. 2.93 times 8.3 is 24.319. So that is our coefficients. Now for our powers of 10, we have 10 to the negative 2, and we have 10 to the negative 5. And when we multiply things with exponents, what we do is we add the exponents. So that's going to be 10 to the negative 2 plus negative 5. And so that will be then 10 to the negative 7. So all together with our coefficient and our power of 10, we get 24.319 times 10 to the negative 7. All right, and is that in correct scientific notation? So we check for correct scientific notation. No, it's not. We must move our decimal so there's only one digit in front of it. That digit cannot be a 0. And we get 2.4319 times, and this half of the number, that just went from 24 to 2.4, so that got smaller by 1 power of 10 because we moved it one place. So this number has to get bigger by 1 power of 10. So bigger in this case would mean less negative, so it would be, instead of 10 to the negative 7, it would become 10 to the negative 6. We've checked for correct scientific notation. Now we have to check for correct sig figs. And we get, oh, go back to our calculation. What were the numbers in our calculation? We had 2 sig figs for the 8.3, and we had 3 sig figs. Our multiplication rule says we must round to the least number of sig figs. So we need to round our answer to 2 sig figs. So this is then going to become 2.4. That's to 2 sig figs times 10 to the negative 6. All right, dividing numbers in scientific notation. This is page 26. We're going to do the same thing, except that instead of multiplying the coefficients, we will divide the coefficients. And instead of adding the exponents, we will subtract the exponents. And then step 3 and 4 are exactly the same. You need to check for correct scientific notation. And then you need to check for correct sig figs. So in general, what it's going to look like is if you have your coefficient times 10 to the x divided by your other coefficient times 10 to the y, that's going to equal, we will divide our coefficient, so that's going to be n over m, and then it'll be times 10 to the x. We're going to subtract our exponents now, x minus y. All right, let's do an example. We have 8.0 times 10 to the negative 3 divided by 2.00 times 10 to the negative 2. So we will divide our coefficients, and this one actually we can probably do in our head, which is really nice, okay, because 8 divided by 2 is 4. So now we have our coefficient, we've divided our coefficient and gotten 4. And now we want to have our power of 10. In order to do our power of 10, we are going to subtract our exponents. So that will then be negative 3, and we want to subtract negative 2. So we now have 4 times 10 to the, and if we subtract negative 2, that's the same as adding 2. So negative 3 plus 2 is just negative 1. Okay, and so we now have our answer, but we need to make sure that we are in correct scientific notation. Oh, we are. Look at that. Only one number in front of the decimal. Are we in correct sig figs, though? No, we're not. We have 2 sig figs here and 3 sig figs here, and the rule for multiplying and dividing is go to the least number of sig figs. So we need to have 2 sig figs. This has only 1 sig fig. So to fix that, we will add an extra 0.0 at the end. So it's going to be 4.0 times 10 to the negative 1. And remember, if you're showing your work, there's so much writing. Box your final answer so your teacher can be like, oh my gosh, look, I can see it. It's good. Okay, let's try another one. 3.45 times 10 to the negative, no, positive 2, sorry, divided by 1.20 times 10 to the negative 5. And so we're going to take our coefficients, and because we're dividing, we divide the coefficients. And so we get 3.45 divided by 1.20, and that is 2.875. Then we are going to subtract our exponents. So we have 10 to the 2 minus, and our second exponent here is negative 5, so it's going to be minus negative 5, which is the same as adding 5, right? So I've now got 2 plus 5, which is going to equal 10 to the 7. Okay? So we get 2.875 for our coefficient times 10 to the 7. Are we in correct scientific notation? Yes, we have only one digit in front of the decimal and it is not a 0. Are we in correct sig figs? Well, go back to your question. 3 sig figs here, 3 sig figs here. Uh-oh, I can only have 3 sig figs in my final answer, so I need to round then to here, and we get 2.88 times 10 to the 7.